Good morning to each and everyone. Sana po ay simulan natin ang Monday ng nakasmile. Ang i-discuss namin ngayon ay ang introduction ng resources and one of its type which is necessary to our society, yung water. Bago po tayo mag-start sa discussion, I have here a spoken word poetry about the importance ng resources na meron tayo. So I hope na makinig po ang lahat for some realizations. Para to sa mga taong hanggang ngayon wala pa rin pakialam, hanggang ngayon patuloy na nagbubulag-bulagan, at hanggang ngayon, sige lang sa pampabaliwala. Heto na. Napapansin niyo ba na sa bawat araw na dumadaan, patuloy ang paglaganap sa napakaraming dahilan, mga pinagkukunan unti-unti nang nababawasan. Nang dahil mismo sa kawalan ng pakialam. Pagkain, tirahan, produkto na meron tayo, sariwang hangin, malinis na tubig, lahat ay galing dito. Ngunit anong ginagawa ng tao? Patuloy sa pang-aabuso. Mga pinagkukunay biyayang bigay ng Panginoon, ngayon, kahapon, pati na noon. Hindi nagkulang sa pagbibigay ng pagkakataon. Ngunit tayong mga tao ang walang disiplina at limitasyon. Yamang likas na meron tayo, sinong hihintayin mong mga laga dito? Yung asong tagabantay ng bahay nyo? O yung pusang nag-aabang ng tinik na ibibigay mo? Masakit mang tingnan ng mga matang ito. Lungkot ang madalas nangingibabaw sa isip ko kapag naalala ang unti-unting pagkasira nito, nang dahil mismo sa ating mga tao. Lunti ang kapaligiran na masarap tingnan, asul na katabigan na ating pinaglalanguyan, mga batong nagpoprotekta sa ating kabahayan. Malinis na kalangitan, madumihay, huwag na nating hahayaan. Sa ganitong paraan ay dahan-dahan, hindi man agaran o tuluyan, maibabalik pa rin natin sa dati ang mundong ating nakagisnan. Kumilos tayo hanggat kaya at pwede pa, huwag kung kailan mawawala na. Gumising ka na sa mahimbing na pagkakatulog mo, huwag puro pasarap sa buhay ang gawin mo, alalahanin mong may responsibilidad ka din sa mundo. Yun ay pangalagaan ang yamang para sa'yo. Introduction. Dito sa lesson na to, we will learn about the different resources na necessary sa ating society like water, soil, mineral and rock, and energy resources, as well as the properties, types, yung problemang kinakaharap, and conservation of these resources ay aalamin natin. Learning outcomes. Tulad ng nakalagay sa syllabus, yung intended learning outcome 2 is to identify the various effects of environmental pollution and describe yung role ng engineers or nating future engineers in the manipulation of materials and resources. Topic outcome is to explain the different resources necessary to human life and civilization. Let us define first what is resource. An environmental resource is any material, service, or information from the environment that is valuable to society. Ito yung anything na nakikita at napapakinabangan ng mga tao para mabuhay like water. All the things we need to survive such as food, water, air, and shelter ay nanggaling sa natural resources. Water as a resource. It is evident that water availability for domestic use, agriculture, and industry is important to everyone. Pero, aware din tayo na most of us ay tinitake for granted lang ang availability nito. Like yung mga pinapabayaang bukas or may tumutulo sa gripo kahit di naman ginagamit. Yung kung makaligo at makagamit ng tubig ay parang wala ng bukas without knowing na yung lack of water may control the extent of development of other resources such as fossil fuels. As we all know, yung fossil fuels cannot be replaced at all. Kaya once na na-use up sila, they are gone forever. Makikita natin dito sa Table 11.1, the water in the hydrosphere, na there is little fresh liquid water on the earth at most ng fresh water is locked up as ice, mainly in the large polar ice caps. Kahit yung mga groundwater beneath continental surfaces ay hindi lahat fresh. With this, the need for restraint in our use of fresh water is a must. Geologically, water is a renewable source, but local supplies may be inadequate in short term. Porosity and permeability of rocks and mineral materials. Porosity and permeability involve the ability of rocks and other mineral materials like sediments and soil to contain fluids and to allow fluid to pass through them. When we say porosity, it is the proportion of void space in the material like holes or cracks and filled by solid material within or between individual mineral grains and is measure of how fluid the material can store. We have high porosity and low porosity. Example ng high porosity ay, halimbawa, meron kang jar. Tapos, meron yung malalaking nuts. Then, you are going to have a lot of space kasi nga malaki ang nuts. Magkakaroon ng large spaces. Therefore, if you have a soil or sediment that is pretty uniform in terms of the particle size and shape, you can expect it to have a high porosity as well. But, kapag meron ka namang different kind ng nuts sa jar, ang iba doon ay maliliit na kayang mag-fit sa pagitan ng malalaking nuts, just like dito sa picture, magkakaroon ng lower porosity dahil may less open space. Porosity may be expressed either as a percentage or as an equivalent decimal fraction. The pore spaces may be occupied by gas, liquid, or a combination of the two. On the other hand, permeability is a measure of how readily fluids pass through the materials, meaning it describes how easily water flows. For example, yung pag-inom natin gamit ang straw. Kapag meron kang large open straw, you can drink water much more easily compared sa small thin straw. Same as if the pores in the soil are large and well connected, water runs through them with a great ease like it does sa large straw. Pero kapag small yon and not well connected, then water has a more difficult time flowing like sa small thin straw. Porosity and permeability of geologic materials are both influenced by the shapes of mineral grains or rock fragments in the material, the range of grain sizes present, and the way in which the grains fit together. Makikita natin dito yung permeability, yung nasa taas at yung porosity naman yung nasa baba. Yung blue bars ay typical ranges ng porosities of various geological materials, then yung brown bars ay para sa permeabilities. Next is subsurface waters. Belong dito yung saturated zone at unsaturated zone. When we say saturated zone, siya yung volume of rock or soil above the impermeable material that is water saturated, in which water fills all the accessible pore space. Kung makikita natin dito sa picture, ito yung saturated zone or phreatic zone. May makikita kayong mga tubig. Yung mga tubig na to sa saturated zone, ito yung tinatawag na groundwater. At saturated zone naman is a rock or soil na nasa ibabaw ng saturated zone. Makikita natin dito sa picture na more on soil siya at yung tubig na nasa unsaturated zone ay tinatawag na soil moisture kung saan important factor ito para sa agricultural productivity. Itong subsurface water naman ay nag-occupy dito sa saturated zone at unsaturated zone, which includes yung groundwater, soil moisture at yung tubig na nasa unsaturated rocks. The water table is the top surface of the saturated zone, where the saturated zone is not confined by overlying impermeable rocks. The water table is not always below the ground surface. Where the water table locally intersects the ground surface, the result may be a lake, stream, spring, or wetland. Yung water surface ay yung water table. The height of water table varies as well. High siya when the ratio of input water to water removed is greatest, typically in the spring, kapag yung ulan ay heavy and snow and ice accumulations melt. In dry seasons or when local use of groundwater is intensive, the water table drops and the amount of available groundwater remaining decreases. Recharge is the processes of infiltration and migration or per location by which groundwater is replaced. From the prefix "re", ibig sabihin, again, napapalitan. Groundwater discharge naman ay nangyayari kapag yung flow ng groundwater ay umalis sa surface ng spring o di kaya exceeds the aquifer. Dito sa picture A, makikita natin na yung groundwater ay palabas or paalis. Dito naman sa picture B, yung tubig na galing sa stream ay pababa para mag-add ng supply sa groundwater. Aquifer is a rock that holds enough water and transmits it rapidly enough to be useful as a source of water. Tandaan natin na aquifer is not an underground river or lake. Ito ay body of rock and sediment that is saturated, kung saan water is in it and around it. Water can also move through it. Aquitard is a rock that may store a considerable quantity of water, but in which water flow is slowed or retarded. An example nito ay yung shale, clay, at unfractured crystalline rocks. Aquiclude was used to describe an extreme aquitard, a rock that is essentially impermeable on a human timescale, but virtually no rock would be impermeable indefinitely, and the term aquiclude has fallen into disuse. Confined and unconfined aquifers. Unconfined aquifer is when the aquifer is directly overlain only by permeable rocks and soil. Dito, if a well is drilled into an unconfined aquifer, the water will rise papunta sa well na kasing height lang ng water table sa aquifer. Kita-kita natin dito sa picture na yung water ay hanggang dun lang sa may water table, nandun lang yung tubig. Next naman is, a confined aquifer is bounded above and below by low permeability rocks or tinatawag na aquitards. Dito naman, if a well is drilled into a confined aquifer, the water can rise above its level in the aquifer dahil ng extra hydrostatic or fluid pressure na tinatawag na artesian system. Kung makikita natin dito sa picture, water level in artesian well, ganito siya kataas. Yung confining layers ang nagpe-prevent ng free flow ng water to relieve yung pressure. Yung potentiometric surface naman ang nagpe-present ng height kung saan ang water's pressure would raise the water if the water were unconfined. Diga yung unconfined aquifer kasing height lang ng water table. Sa confined aquifer naman, mas mataas yung water level niya or it may be above the ground surface.
Consequences of groundwater withdrawal. So, ang pinaka-severe na consequence ay yung excessive groundwater pumping is that the water table below which the ground is saturated with water can be lowered. For water to be withdrawn from the ground, water must be pumped from a well that reaches below the water table. Pag yung groundwater ay dinecline na pag malayo, kailangan nung well owner ay ipalalimin palalo yung pagdidrill. So, sa count of depression, ito yung circular lowering of water table immediately around the well in an unconfined aquifer. Kapag marami yung space ng mga wells yung na malalapit, ay maaaring magkaroon ng overlap sa cone of depression na makikita nyo sa larawan na ito. Cones of depression can likewise develop in potentiometric surfaces when artesian groundwater is withdrawn at a rate exceeding the recharge rate. The potentiometric surface can be lowered. Tapos, groundwater flow rates are highly variable, but in many aquifers, they are of the order of only meters or 10 meters per year. Recharge of significant amounts of groundwater, especially to confined aquifers with limited recharge areas, can thus require decades or centuries. So, may dagdag ko lang dito na pag yung groundwater is being depleted by too much, withdrawal too fast, one can speak of mining groundwater. Hindi naman yung idea na necessary na yung water ay hindi na marirecharge. Pero yung rate ng niya slow lang. Parang sa human time scale ay insignificant. Tapos sa human activities, may themselves reduce natural recharge, so groundwater consumed may not be replaced, even slowly. Compaction and surface subsidence. If the aquifer rocks are no longer saturated with water, they may become compacted from the weight of overlying rocks. As the rocks below compact and settle, the ground surface itself may subside. Maaari mag-collapse yun. Na kung saan yung water ay surface subsidence may be several meters, lang. Malapit lang. Tapos, kapag nilower pa yung water table, maaaring magkaroon ng sinkhole dun sa baba. Tapos, the city of Venice, Italy, is in one such slowly drowning coastal area. Dun pala sa mga high elevation or inland areas, yung subsidence ay nagkokos lang ng structural problems na kung saan yung building formation ay nasira. Tapos sa mga low elevation coastal regions, the subsidence may lead to extensive flooding as well as to increased rates of coastal erosion. Tapos, ito naman, ang Metro Manila naman ay yung grabe yung kapag may bagyo, grabe yung baha, kasi dahil ng overpumping ng groundwater, dahil din ng overpopulation. Saltwater intrusion. Ito yung isa pang problema pag sa groundwater na ginagamitan ng coastal regions. Thus, fresh water falling on land does not mix so readily with saline groundwater at depth because water in the pore spaces in rock or soil is not vigorously churned by currents or wave action. Tapos, yung fresh water is less dense than salt water. So, the fresh water accumulates in a lens which floats above the denser salt water. And if water use approximately equals the rate of recharge, the freshwater lens stays about the same thickness. If consumption of fresh groundwater is more rapid, the freshwater lens thins and the denser saline groundwater laden with dissolved sodium chloride moves up to fill in pores emptied by removal of fresh water. So, upconing of salt water below cones of depression in the freshwater lens may also occur. Wells that had been tapping the freshwater lens may begin pumping unwanted salt water instead, as the limited freshwater supply gradually decreases. So, dito sa saltwater intrusion, once yung section ng aquifer ay ma-contaminate with salt, hindi na to magiging fresh ulit. Impacts of urbanization on groundwater recharge. An increasing concentration of people means an increased demand for water. So, ang urbanization, it involves extensive modification of surface water runoff patterns and stream channels. As it modifies surface runoff and the ratio of runoff to infiltration, urbanization also influences groundwater hydrology. Impermeable cover such as buildings, yung mga asphalt, concrete roads, sidewalks, mga parking lots natin, tsaka yung mga airport, runways, are over one part of a broad area underlain by an unconfined aquifer has relatively little impact on that aquifer's recharge. In a confined aquifer, the available area may be very limited since the overlying confining layer prevents direct downward infiltration in most places. So, kapag sinabing confined aquifer, yun yung nasa ilalim ng yung below the land surface na merong saturated with water. Tapos, yung layers of impermeable material ay both nasa baba at taas. Ayun yung aquifer na causing it to be under pressure so that when the aquifer is penetrated by a well, yung tubig ay tataas sa itaas ng aquifer. So, kapag yun namang paano pag ang tanong ay how do confined aquifers recharge? So, since groundwater in a confined aquifer is under pressure, artesian wells can exploit the pressure, yung from head difference to draw the water to the surface. Recharge refers to the process by which an aquifer is replenished with fresh water. So, makikita nyo dito sa left na yung recharge area, confined aquifer is limited to the area where permeable rocks intersect the surface. So, makikita nyo yung kulay dilaw, yung recharge zone of aquifer, limited lang yun sa area na yon. So, yung makikita nyo yung line pababa, yun yung aquitards na yun yung infiltration to aquifer. Kaya tinatawag yun na aquitards. So, sa right side naman ng picture, recharge ceases after construction and placements of impermeable cover over recharge area. Little or no infiltration where aquifer is confined. With continued water use, water level in aquifer drops. Impacts of urbanization on groundwater recharge. Sa filling in wetlands, ito yung common way para mag-provide ng lupa para sa construction. This practice can interfere with recharge, especially if surface runoff is rapid elsewhere in the area. A marsh or swamp in a recharge area that is holding water for long periods can be a major source of infiltration and recharge. Filling it in so water no longer accumulates there and topping the field with impermeable cover may greatly reduce local groundwater recharge. Sa steeply sloping areas or those with low permeability soils, well-planned construction that includes artificial recharge basins can aid in increasing groundwater recharge.
Artificial recharge basins can aid recharge by slowing surface runoff. The basin acts similarly to a flood control retention pond in that it is designed to catch some of the surface runoff during high runoff event. Recharge basins are a partial solution to the problem of areas where groundwater use exceeds natural recharge rate, but they are effective only where there is surface runoff to catch and they rely on precipitation. So, ang recharge basin po, ito po ay isang uri ng aparato na ginagamit upang pamahalaan ang pag-agos ng bagyo, maiwasan ang mga pagbaha at pagguho ng downstream, at para rin pagbutihin ang kalidad ng tubig sa isang kadabing ilog, lawa o bay. Karst and sinkhole. Rock types such as carbonate rocks or beds of rock salt or gypsum, chemical sediments deposited in shallow seas are extremely soluble in water. Dissolution of these rocks by subsurface water and occasional collapse or subsidence of the ground surface into the resultant cavities creates a distinctive terrain known as karst. Karst is a topography formed from the dissolution of soluble rocks such as limestone, dolomite, and gypsum. It is characterized by underground drainage systems with sinkhole and caves. It has also been documented for more weathering-resistant rocks such as quartzite and the given right conditions. The underground water dissolving large volumes of soluble rocks over long periods of time that slowly enlarging underground caverns can also erode support for the land above. There may be no obvious evidence at the surface level of what is happening until the ground collapses abruptly into the void, producing a sinkhole. A sinkhole is a depression or hole in the ground caused by some form of collapse of the surface layer. The collapse of sinkhole may be triggered by a drop in the water table as a result of drought or water use that leaves rocks and soil that were previously buoyed up by water pressure unsupported. Where there is one sinkhole in a region underlain by such soluble rocks, there are likely to be others. An abundance of sinkholes in an area is a strong hint that more can be expected. Water quality. The water on and in the continents is not all fresh. Rainwater is not considered as pure water because it contains dissolved chemicals of various kinds, especially in industrialized areas with substantial air pollution. Water quality is important because it connected to our health, what we drink and what we use while taking a bath or kung ano pa man. Ito ay pwedeng makaapekto sa health natin. Some says that rainwater is safe, but nowadays rainwater is unsafe due to the chemical na nanggagaling sa mga industrialized areas. Isa pa ay dahil sa air pollution. Water quality may be described in a variety of ways, like to express the amount of a dissolved chemical substance present as a concentration in parts per million, or for very dilute substances, parts per billion. Total dissolved solids, or TDS, is one of the parameters used in describing water quality, the sum of the concentrations of all dissolved solid chemicals in the water. The level of TDS required or acceptable varies with the application. And TDS seems to be like a guideline sa water quality kasi po ini-ensure niya na safe yung tubig sa health natin. At dito din malalaman kung pasado ba sa health ang klase ng tubig na yon. Kung makita na maraming chemical content, then hindi siya acceptable sa application sa water quality. Hard water simply contains substantial amounts of dissolved calcium and magnesium. So hard water ay yung water na maraming calcium at magnesium na content. Kung hard water ang ating ginagamit sa panliligo or gagamitin natin sa panliligo, especially dun sa mga sensitive ang balat, nagkakos siya ng irritation at minsan ay eczema pa. Here in the Philippines, you may refer to DENR AO 2016-08, also known as the Water Quality Guidelines and General Effluent Standards, for the significant parameters need to monitor per industry and the allowable value of these parameters. Also stated there is the classification of water in the Philippines. So having a guidelines about sa water quality is very important and helpful para sa atin. Kasi mas sinisecure nun yung safety ng health natin, lalo na at water is our primary needs. Extending the water supply. Conservation. Water is wasted in home, used every day by long showers, inefficient plumbing, insistent on lush, green lawns even in the heat of summer, and in the dozen of other ways. So sa alternatibong diskarte, mapapalawak ang mapagkukunan ng tubig sa pamamagitan ng pag-aalaga. Ang isa pang paraan ng paggamit nito ay dapat kaunting tubig lamang ang ating kinukonsumo. Irrigation use must be moderate if the depletion rate of water supply is to reduce appreciably. However, the more efficient methods are often considerable more expensive too. Domestic use can be reduced in a variety of ways. Municipalities in dry areas are looking to recycle their wastewater. Interbasin water transfer. People persist in settling and farming in areas that may not be especially well supplied with fresh water, while other areas with abundant water go undeveloped. If the people cannot be persuaded to be more practical, perhaps the water can be redirected. This is the idea behind interbasin transfer, moving surface waters from one stream system's drainage basin to another's where demand is higher. Interbasin water, so sinasabi po dito na ang mga tao daw po ay patuloy na nire-resolba kung paano ba ang pagsusupply ng malinis na tubig sa mga lugar. Kung ang mga tao ay hindi magpupursige sa pagiging praktikal, marahil ang tubig ay hindi nakadirekta. Ang interbasin transfer ay ang pagdaloy ng tubig galing sa isang stream system drainage basin hanggang sa iba kung saan tumataas ang demand. Desalination. Desalination of seawater would allow parched coastal regions to the top vast ocean reservoirs. These are two basic methods used to purify water of dissolved minerals: filtration and distillation. So in a filtration system, the water is passed through fine filters or membranes to screen out dissolved impurities. An advantage of this method is that it can rapidly filter great quantities of water. A disadvantage is that the method of work based on water not containing very high level of dissolved minerals. Ang proseso ng pagtatanggal ng asin sa tubig dagat o desalination, kung saan tinutuyo ng init patungo sa malawakang karagatan na tinatawag na malawak na karagatan. Nabanggit din dito na may dalawang uri ng pangunahing aplikasyon para sa paglilinis ng tubig. Yan ay ang tinatawag na filtration at distillation. Ang pagsasaayos ng proseso na kung saan hinihiwalay ang solid to liquid gas gamit ang filter medium na hinahayaang lumampas ang fluid. Ang tubig ay dadaan sa masusing proseso kung saan matatanggal ang mga bakterya o dumi na pumapaloob sa tubig. Ang masamang dulot nito ay ang mas gumagana lamang ito sa tubig at hindi sa may mga mataas na level na natutunaw na material. Distillation involves heating or boiling water full of dissolved minerals. The water before driven up is pure water while the minerals stay behind in what remains of the liquid. The disadvantage is the nature of the necessary heat source. Furnaces fired by coal, gas, or other fuels can be used, but any fuel may be costly in large quantity, and many conventional fuels are become scarce. Desalinated water may be 5 to 10 times more costly to deliver than water pumped straight from a stream of distillation. Ito ay pumapaloob sa pagpapainit at pagpapakulo ng tubig upang matunaw ang mga mineral. Ang kasamang epekto nito sa ating kalikasan ay ang init na dala. Nagsasara gamit ang carbon, gas at iba pang pampaningas na magagamit, ngunit ang ibang fuel ay mahihirapang makuha. Ang distilled na tubig ay may 5 hanggang 10 beses at nakakaapekto sa paghahatid kaysa sa water pump na nakukuha at nanggagaling mismo sa sapa o batis. Desalination. In areas such as the arid Middle East, the more acute need for irrigation water has made desalinated seawater is viable agricultural option economically. A massive Israel desalination plant began providing desalinated water from the Mediterranean Sea for domestic and agricultural use in late 2015. Sa mga lugar katulad ng arid Middle East ay nanganganib at kinakailangan ng supply ng tubig na nanggagaling sa desalinated seawater na isang maaari o panghalinhin ng agrikultural na ekonomiya. Sa massive Israel desalination plant naman ay nagbibigay ng desalinated water galing sa Mediterranean Sea para sa domestic at agricultural na ginagamit noong taong 2005.
So, that would be all. Sana po ay marami kayong natutunan at laban lang future ingenieros. Thank you and God bless us all.